Hey again, this is video part 2 of section 2 for chapter 5. It is again dealing with bisectors. This was the first tab where we did some circumscribing. Now we're gonna, and this was perpendicular bisectors, right? We took the side, cut it in half, and drew a perpendicular line through that. And now we're going to talk about not bisecting the side, but bisecting the angle. So as I draw this around, it's going to be a little more difficult to see. But what you're going to notice is that this line, focus on this line right here. This line right here is always bisecting this angle. It's always cutting in half. Now that wasn't the case over here. In fact, most of these never even went through the angles, right? This right here, it's always going through. And again, what we can see is that this point right here is the intersection of all three of those every time. Now, what might we be able to create with this one? Now, this program here, GeoGebra, doesn't do as good of a job. I'm a little disappointed with its ability to draw this circle. I'm going to again draw a circle for you, but the circle will only work once. In fact, let me move this triangle to something like this. It's a nice scaling, acute kind of thing. So I draw this, I grab this, and as I move this out, what you'll notice is that it just touches all three sides perfectly, which is pretty neat. Yeah, neat, says the math teacher. And what we so what we can see then, no matter how I move this circle around, no matter how I move this triangle around, the circle is always going to be inside this triangle. And I wish that I could make it work that way every time, but GeoGebra just doesn't have that ability. But you can trust me when I say that as I move this around, this circle will change sizes and it will always be inside. So whereas this right here, yesterday, the earlier video, the circumscribed circle was the smallest circle that will contain the triangle with all three vertices. This one here is actually the smallest or the biggest circle that can be drawn inside. So this is actually called inscribing. This has been inscribed inside the triangle, and this right here, center point, is called the incenter. So the intersection of the angle bisectors is called the incenter, and with that we can inscribe circles inside. Circumscribe circles outside, inscribe circles inside. That's all I got for now. See you next time.